So this is a short presentation on the Nickel-Biochar regenerative sorption platform. Let's start. This is Kodaikanal. It's absolutely beautiful valley in South India that unfortunately has been the site for some of the most disastrous heavy metal contamination in the world. Basically, a thermometer factory in the 90s and in the early noughties was just discarding very negligently all of its mercury contaminated glass. Now, I visited this area in 2018 as part of a research trip and decided to define my PhD on technologies to remediate some of the heavy metal contamination. Now, heavy metals being elements don't break down, so they just cycle through the ecosystem, causing toxicity and mutagenesis everywhere they go, and they cause toxicity and mutagenesis at ridiculously low concentrations. Above 2 parts per billion, mercury will reliably cause mutagenesis in pretty much every living thing. So these pollutants are extremely persistent. They need to be removed from the environment, and the only way that can work is if they can adsorb onto something. In my research into particular types of sorption media, I settled on biochar. Now, what is biochar? Let me just remove this. Biochar is it's essentially a biomass that's been cooked in an oven with a very limited amount of oxygen, very similar to activated carbon or charcoal. Now, because it can be made from pretty much any biomass, you can make it from the kinds of agricultural waste that have no economic value whatsoever, which means it's almost essentially free. And the pyrolysis process that you use to actually produce it is actually very accessible. But as a sorption medium, it's particularly interesting because it has a very high internal surface area. It's basically got this labyrinthine porosity, which allows it to be extremely physisorptive. That is, it traps molecules and large atoms in its pores. And that surface is also highly adaptable, it's highly reactive, and it has essentially become a kind of plaything for chemists and material scientists around the world for decades to produce all kinds of extremely interesting functionalizations on not just a biochar, but an activated carbon internal surface. But lastly, and this is one of the main reasons I chose it, it's an established medium for remediation. What this means is there are very few heavy metal remediation facilities in the world, and the ones that do exist typically use activated carbon as a feedstock. That's because for certain kinds of industrial pollution that has a high concentration of heavy metals, they'll put it through a granulated activated carbon filter. It's not particularly selective and it's not particularly effective either, but it does mean that the economy that's already set up for dealing with heavy metal contamination deals with these kinds of carbonaceous sorption media. So I came into my PhD thinking that I would go and produce all kinds of interesting functionalizations, and the more I looked into the functionalizations of carbonaceous materials, the more I realized this is a deluge of some of the most interesting research that exists. People have, as I said before, been functionalizing the internal surface of biochar and activated carbon and charcoal for ages, and they produce some incredible materials for the removal of all different kinds of heavy metals and other persistent pollutants. So instead of adding to this deluge of extremely interesting research, I was more interested as to why this hasn't left the lab. And instead of adding to it, I decided instead I would produce a platform, something where I could take some of this research that exists in the lab and try and bring it into the real world. And this is some of the work I'm researching. Essentially what I do is I take a biochar and I coat it onto a nickel foam. That's just a piece of nickel metal that's been made into a kind of sponge with connected macropores. And I do this via a method called EPD, which is relatively well established. This produces a coating which can then be functionalized. Now, all those functionalizations I just talked about before, all this really interesting research, that can be done chemically, but because I'm producing an electrode of this nickel biochar composite, I can also do electro-functionalizations. I can electroplate it in various forms, which is extremely interesting for metal nanoparticles, which are obviously very important for life sciences, but are also very important for the selective capture of different heavy metals. Now, that final composite can then be used as a filtration medium where a specific pollutant, in my case right now, mercury in extremely low concentrations, can be selectively removed. And then here comes the innovative step. The idea here is to reverse the EPD process, because the nickel foam, whilst it's relatively cheap, is not massively sustainable. It shouldn't be used as a consumable material. And if you're going to contaminate a nickel foam or any other expensive metal like this with heavy metals, all you've done is produced very expensive waste. So instead, I recycle it. I recycle the nickel foam using the EPR process, and what this produces is a very concentrated biochar, a biochar very concentrated with the particular pollutant, which can then be sent to the remediation facilities which are already set up to deal with activated carbon. I would present a lot more details on this, but the research is ongoing and papers to be published soon, and hopefully patents soon thereafter. Thank you very much for your time.